In this lesson, we'll talk about security in web applications. Security is probably something you don't really worry about much when you develop a desktop application. For example, if you look at something like Eclipse, as complex as a piece of software it is, you don't really need to log in to use it, and it doesn't try to prevent you from using some of its features because you are not an admin user or something. If you think about it, there are several reasons why we don't really need to worry about security for desktop applications. First, the number of users who can access this software is limited, and their identities are usually known. For example, only you can use your laptop, only your family members can use a family computer, and only students can use lab computers, and so on. This allows us to trust the users to some degree. And second, desktop software usually don't need to deal with different user types, and consequently there's no need to implement access control. Finally, and probably most importantly, desktop software can rely on the operating system for security. In particular, the operating system will handle login, logout, and access control so the application doesn't have to. On the web, things are quite different. As soon as you deploy your web application on a server, people all over the world can access it, and you can bet that some of the users will want to break your application for fun or for profit. It's also quite common for web applications to support different types of users. For example, in a web forum application, you would have regular users, forum moderators, and administrators, each having different privileges. And on top of those, there's no operating system to rely on, so web applications often need to implement security themselves. When we talk about web application security, we usually mean three things: authentication, authorization, and connection security. Authentication is a process of establishing the user's identity, usually by checking username and password. After we know who the user is, we still need to check whether that user is allowed to access a particular resource, and that's called authorization, also known as access control. In addition to authentication and authorization, we also want connection security, so people who eavesdrop on our network cannot steal our passwords and credit cards and so on. Out of the three, connection security is usually implemented outside a web application. So let's talk about connection security first, so we can get it out of the way. The answer to connection security is basically one word: HTTPS, which stands for HTTP over SSL or TLS. You can configure your application server to use HTTPS, and once that's done, you can be reasonably sure that the connections between the clients and the server are secure. The SSL in HTTPS stands for Secure Socket Layer, which is a communication security protocol that deals with server authentication, client authentication, and connection encryption. TLS is basically an updated version of SSL. SSL server authentication is very widely used these days. For example, when we buy something on Amazon, server authentication makes sure that the website is indeed Amazon.com, not some fake site set up by some hackers. SSL client authentication is also used in some systems, like banking websites, where you use a digital certificate to log in instead of using username and password. Connection encryption, of course, prevents people from eavesdropping on network connections. SSL and TLS are usually covered in security/networking classes, so we won't get into details here. For us, we are more interested in the security at the application level. Here's a simple example showing how we can implement security programmatically. Here I have two simple JSP pages. One is called members.jsp, and it displays something like welcome to members only area. And in this JSP, we check for a particular session attribute called username. And if this particular session attribute is not present, we send the user, redirect the user to the login.jsp. And if user clicks log out, this part of the code would invalidate the session and then send the user to login.jsp again. And in the login.jsp, we have a login form, which is a very simple HTML form, username, password, login. And if the user clicks the submit button, it will send a login parameter, and this part of the code will check username and the password. And if they match CY-SOM, ABCD, it will set a session attribute username and then redirect the user to members.jsp. Let's quickly run this code and make sure it works. Okay, so let's first click on members.jsp. We haven't logged in yet, so we should be redirected to, we should be redirected to login.jsp when we click on members.jsp. So members, redirect to login.jsp. If we give it the right username, password, login, and members.jsp is shown, refresh is still shown, log out, and then refresh again. Now we can no longer see members.jsp. So it works, and the code is reasonably straightforward. Security implementation this way is known as Programmatic Security, as we are literally programming security ourselves. The good thing is that we can implement any security mechanism this way, but the bad thing is that this is quite tedious to do. This example doesn't look too bad because we only have one operation here, which is to display the members page. But a more complex application can easily have tens or even thousands of operations. It's very tedious if we have to check if a user has logged in and then check if the user has the access right for each operation. And on top of that, writing security code is notoriously difficult. The more security code an application developer has to write, the higher chance of some security hole in the code. So programmatic security is not only tedious, but often not that secure. So what's the alternative? Remember that desktop software can rely on the operating system for security. The same concept applies to web applications as well. And for web applications, the operating system is the application server. For Java web applications, the Java EE standard requires that Java application servers provide 4 types of security: HTTP Basic, HTTP Digest, HTTPS Client Authentication, and the PhoneBased Security. Now, let's see an example of HTTP Basic. So, this is my web server, sun.calstatela.edu. If we log on to the server, and here we can see that on the server I have a folder called CS520, and under that folder there's a file called hello.txt, and we can try to access that file. So it's /cy sum cs520 hello.txt. And if we try to access that file, notice that the file itself is just a simple text file. But when we try to access it, the browser will pop up a window and ask for username and password. That's because currently this folder CS520 is protected by HTTP Basic Security. So how does this thing work? To enable HTTP Basic, the way to configure HTTP Basic depends on the web server you are using. I'm using Apache HTTP server on my server, and there are a few different ways to enable HTTP Basic Security, and the easiest way, in my opinion, is to use a file called .htaccess. This is a file you can create and place under the folder you want to protect, and it's a hidden file. Notice that it starts with a dot, and on Linux systems is the convention for a hidden file. If you look at the content of this file, you can see that it says authentication type basic, indicating that it's using HTTP Basic Security, and there's a name for the authentication realm, and that name can be anything. I'm calling it CS520 Security Example 1, and it needs the file that contains username password, and this is the file that contains the username password, and the last line that says require either all authenticated require user to be any authenticated user or a specific user in this file. And here I'm requiring that anybody who wants to access this folder must be this user CS520. So if we look at that, password file, we can see that this is the username and this is the password. Okay, so once we have this file in the folder, that folder and all its subfolders will be protected by HTTP Basic. What happens is that when a client sends a request to any resources under that folder, the server will send back a response requiring asking for username and password, and then the client will need to resend the request with the username and password. Now let's quickly set up TCP/IP monitor and see this exchange between the client and the server. So the server is going to be some.calstatela.edu, some.calstatela.edu. The port is going to be 80, and the local monitoring port is going to be 6000 as before. Let's start. Okay, so I'm going to change this one to localhost 6000. Okay, so we are presented with this login box again. Now, if we see what's being captured by TCP/IP monitor, so on the left-hand side is a request to get this hello.txt file. On the right-hand side is a response. Notice that the response has a status code of 401, and it says unauthorized, and is asking for username and password. Once the browser receives a response like this, the browser will automatically pop up a username and password asking the user to give a username and password. So this is the server response, and this particular header and this status code indicates that the resource is secured by HDD Basic, and the browser will pop up a username and password window like this. Now, if we type in CS520ABCD and then click OK. And now we can see this hello world.txt, and if we go back here, we can see that the browser sent a second request to the same URL, but this time this request has a header that says authorization basic and then something like this, which is actually our username password. And the response of this request has a status code 200, meaning that the request is successful, and we can see the file here. Now, you may be wondering that what exactly is this thing, and this thing is actually the username password encoded in the base64 using base64 encoding. So if we want, we can decode this one. So copy here and paste here, click decode. So this is what's being sent in the request. It really is the username and the password. So this is how HTTP request works. And as we just saw, HTTP Basic. So this is how HTTP Basic works, and as we just saw, HTTP Basic is pretty easy to set up and pretty easy to use. The problem is, however, that the username and password are sent in essentially plain text. Base64 encoding is an encoding type, it's not an encryption type. It's simply convert all the characters into some displayable form. In other words, they are essentially still username password in plain text. And the problem with this is that if there's somebody eavesdropping on the network, they can easily store the username password. So how can we improve HTTP Basic? Well, you would think that a pretty straightforward way is to simply encrypt username and password, so that even when they are stolen, the attacker or the hacker cannot simply use the username password. And if we continue with that line of thought, we may be thinking that, okay, we can probably use one of those so-called cryptographic hash functions to do the encryption. A cryptographic function can take a string of arbitrary length and transform it into a value of n bits called a digest. Here are several properties of a cryptographic hash function must possess. The first property says, given a hash value, it's virtually impossible to find a message that's hashed to this value. So what this means is that we can go from this to this. But if we are given an n-bit digest, we cannot decrypt it and find the original message. So this property in particular gives a nickname of cryptographic hash functions, and the people often call them also one-way hashing, because we can only go from this direction, but not the other way around. So the second property basically says that given a message, it's virtually impossible to find another message that hashes the same value. And the third property says it's virtually impossible to find two messages that hash to the same value. These properties ensure that when an attacker captures an encrypted username and password, they cannot recover the original one, and that's the first property. and nor can they come up with a fake username and password that hash to the same value, and that's ensured by the second property. And because of this, one-way hashing is commonly used for storing passwords, software checksum, digital signatures, and so on. There are many cryptographic hash functions, and the popular ones are MD5 and the SHA family of algorithms. These days, MD5 and SHA1 are no longer considered secure. The recommendation is to use SHA256 and 512. One of the common usages of cryptographic hash functions is for storing passwords. Since storing passwords is something most web applications have to do, I'd like to discuss this a little bit. The first question you may have is, why do we want to encrypt stored passwords in the first place? Remember that passwords are used to gain entry to an application. If some hackers break through all the security measures and gain access to the database where the passwords are stored, they can also access all the other data in the application. So what's the point of protecting passwords when the hackers are already in the system? The answer is that encrypting passwords is not for protecting the application, but for protecting the users. The reason is that it's quite common for users to use the same password for different systems. If a password is stolen from one system, there's a good chance that the same password can be used to gain access to other systems. So the main purpose of encrypting stored passwords is to prevent stolen passwords to be used on other systems. Another question about encrypting passwords is, how do we check user credentials if it's impossible to decrypt the passwords? The answer is that instead of decrypting the stored passwords, we encrypt the password the user entered and compare it to the stored password in its encrypted form. These days, there are two common types of attacks against encrypted passwords: brute force and brute force, which tries all combinations of characters up to a certain length, and the dictionary-based attacks, which target common passwords and passwords that consist of simple variations of common words. The most effective way to defend any attack is to use passwords that are very long and random. But unfortunately, such passwords are difficult to remember, so most users don't use them. For application developers, there are a couple of ways to help the users better protect their passwords. The first is to make cryptographic hash functions slower by repeatedly applying the same function many times, and this helps slowing down the brute force attacks. Another way is to use sort, which is a unique random value added to each password. Sorting is very effective against dictionary-based attacks. Now that we know about one-way hashing, it seems like we can easily improve HDD Basic by simply encrypting the username and password. However, if you think about it, such a measure won't work because the attacker only needs the encrypted username and password for login purpose. In other words, an attacker never needs to decrypt the username and password, so encrypting them achieves nothing. Because of that, HTTP Digest Security goes a step further than just encrypting username and password. Here's an illustration of a HTTP Digest exchange between a client and a server. Compared to HTTP Basic, the differences here are A, the server will send a random value to the client called a nonce, and B, the user credentials are encrypted in something called a message digest. Here's a sample server response with a nonce, and here's a sample client request with a message digest. Notice that the message digest is a hash value of the combination of several things. It's the combination of username, password, rel, URI, server nonce, client nonce, request counter, and the quality of protection value. Of all these things, the request counter NC is actually the most important. Without this, an attacker can perform a so-called replay attack, basically capturing this request and resend it to gain access to the requested resource. With the request counter, however, replay attack no longer works because the server would expect the next request to have the counter value NC plus 1 instead of still NC. Because in HTTP digest, the server must maintain a request counter for each client. It has a negative impact on server performance. And at the same time, HTTP digest does not protect any data other than username and password, which means, for example, an attacker can still capture your credit card number after you log on to Amazon.com. Probably because it's too much trouble for too little protection, HDD digest is rarely used. The third security measure a Java EE application should support is HTTPS client authentication. Because it's part of SSL, as I mentioned earlier, we'll leave it to a networking/security class. Now let's talk about the fourth one, called PhoneBased Security. Unlike HTTP Basic, HTTP Digest, and HTTPS Client, which are all general HTTP security specifications, PhoneBased Security is specific to just Java EE application servers. Now let's look at an example of PhoneBased Security. Well, first let me stop the TCP/IP monitor, and then let me stop the server, and the first thing we do is we're going to add a couple of users and roles to this file called Tomcat users.xml. This is the file Tomcat uses for phone-based security, and within Eclipse it should be under servers, and then here Tomcat users. Here, as you can see, there are some examples of users and roles, and they are all commented out. That's okay. We are going to create a few new ones anyway. And the first one I'm going to create is a user called admin, and this user has a password 1234, and this user will have two roles. One is the admin role and one is the member role. Actually, let me double check whether the role should be called member or members. Yeah, it's just member. Okay, so this user is both an admin and a member. And let's create a second user, CYSum, password ABCD, and CYSum is just a member. So phone-based security uses role-based security, meaning that the access is determined by the role of the user. And the good thing about role-based security is that a user can have multiple roles like this. Okay, so now we have our users and roles, and then let's take a look at web.xml. This is where the role-based security constraints are specified. Not role-based security, form-based security. Sometimes my brain thinks of one thing and the words coming out of my mouth are different, so forgive me for that. Okay, so the first thing we notice is that here it says login config, and then the authentication method is called form, and this declares that this application will use phone-based security. And to use phone-based security, obviously we need to have a login page, and if login failed, there should be an error page. So this is a login, this is the error. If you look at the login page, it's just a regular HTML page. It's not even JSP. There's no JSP code anywhere. Just a regular HTML page, HTML form, and so on. And similarly, the error page is also just a regular HTML page. There's no code in there, just HTML tags. And here it says login failed. Now, this allows us to allow users to log in. That once a user logs in, we need to specify the access control on the authorization part of security. And those are specified using the security constraint tag. So the first one says that for anything starts with /admin/ or in other words, if the URL falls under this folder, we require that the user must have the admin role. And for anything that falls under the members folder, the user must have either the admin role or the member role. In other words, an admin user can also access the member area, but only admin user can access the admin area. So this is pretty much it for the security configuration. We specify the login forms and error page, and then some access control rules. The layout of the application looks roughly like this. We have our login page and logout page, which essentially does session invalidation, and the error page and the index page, and the configuration in web.xml. Notice that I also have two other pages. One is called index.html under the admin folder, and one is the index.html under the members folder, which is this one and this one. So again, notice that both of these two pages are regular HTML pages. In fact, if you look at the whole application, there's no code in anywhere other than in the login JSP where we do a session invalidate. Everything, all the other pages are just regular HTML pages. Okay, so now let's run this. And so suppose I click on admin index.html, and since I haven't logged in yet, the application server automatically sent me to the login page. So remember that we have two users. One is called admin, one is called CYSUN. Let's say we try to log in as CYSUN ABCD. Okay. Notice that the error message here is access to the requested resource has been denied. It doesn't say authentication failed, meaning that we actually were logged in successfully. But because the user CYSUN only has a members role, the user CYSUN, the user CYSUN only has the role member, and accessing anything under admin requires a role admin. That's why we are getting a access denied error. So if I back out here and I do a logout, and we try this again, but this time we'll log in as admin 1, 2, 3, 4, and we can see that now we can see this page successfully. And same thing for members. And if for this page I log in as CYSON ABCD, and I can see this page without any problem. But if I try to access the admin page, again, I'm going to see this access denied error. Okay, so this is how form security works. By and large, it's pretty straightforward, but there's one thing we haven't mentioned, and you may be wondering, which is that where does the authentication happen? Right? We know that this logout part happens here. We do a session invalidate. But where does login happen? Because we didn't write any code for logging in. We didn't write any code to check whether the username is CYSON, the password is ABCD, and so on, right? So all that seems to be taken care of by the application server. But how? Well, the how is actually here. Notice that although this login form is a regular login form, but the URL for the action and the parameter names for username and password are kind of special. And this is where essentially authentication happens. So instead of writing authentication code ourselves, what we are doing is we are submitting the login information to a special URL, and that special URL is j_security_check. So this URL is actually handled by the application server, and in our case is handled by Tomcat. So once Tomcat receives a request at this URL, Tomcat will look for two special parameters. As you would guess, it's j_username and j_password. So Tomcat actually has code to do validation of this username and password against whatever that is stored in Tomcat users .xml. And so, in other words, the authentication part is taken care of by the application server, and all we need to do is make sure that the username is called j_username, password is called j_password, and they are submitted to the special URL j_security_check. Okay, so this is phone-based security, and phone-based security and security like HDD Basic are known as Decorative Security. What it means is that instead of implementing security ourselves in the application code, we can simply declare some security constraints in some metadata files, like the .htaccess file or the web.xml file. The advantages are obvious. Just like desktop applications that can rely on operating systems to provide security, web applications now can rely on application servers, which are effectively operating systems for web applications. Security now is much easier to implement, use, and maintain. Unfortunately, there are also some drawbacks when it comes to decorative security provided by application servers. First, is application server dependent. For example, Tomcat uses a file tomcat_users.xml to store the users, and some other applications may use a different file or database or some directory service. Second, it's often not flexible enough. For example, with Tomcat's phone-based security, there's no easy way to register a new user. And lastly, it should be noted that when it comes to access control, the servlet specification only requires URL-based access control, which means that it only does access control based on some URL patterns like this. As we'll see later, sometimes we'll need the access control at a much lower level.